Welcome to a gentle journey through the fascinating world of reptiles. As you settle in and let your body relax, we'll explore these ancient creatures together. There's no need to remember everything, just let the facts wash over you like a warm breeze as you drift into peaceful rest. Let's begin with something truly remarkable. There are about 12,000 known living reptile species sharing our planet, and even now, scientists are still discovering new ones. Imagine that 12,000 different kinds of reptiles, each one perfectly adapted to its own corner of the world. Some are as small as your fingertip, others larger than a car, and somewhere out there in a rainforest or a desert we haven't fully explored. There may be species we haven't even met yet. These incredible animals have spread across almost our entire planet. Reptiles live on every continent except Antarctica. They need warmth from their environment, drawing heat from the sun and the earth beneath them, and the extreme cold of Antarctica is simply too much for their bodies to handle. But everywhere else, from steaming jungles to sun-baked deserts, reptiles have found a way to thrive. Think of all the different places on Earth, and you'll find reptiles there. They live in deserts, where the sand holds the heat of the day long into the night. They live in forests, both on the ground beneath the canopy and high in the trees above. They live in grasslands, gliding through tall grasses in search of food. Some make their homes in freshwater rivers and lakes, their bodies perfectly designed for swimming. Others prefer wetlands, those mysterious places where water and land meet. And some reptiles, perhaps the most adventurous of all, have even made the vast oceans their home. All of these 12,000 species, diverse as they are, can be grouped into four main orders. First, there are the turtles, ancient creatures carrying their homes on their backs. Then the crocodilians, powerful predators that have barely changed in millions of years. The largest group includes the lizards and snakes, incredibly varied in size, shape, and lifestyle. And finally, there are the tuataras, mysterious reptiles that we'll learn more about in just a moment. If you were to travel to Australia, you would find yourself in a reptile paradise. Australia has an especially rich reptile fauna, with hundreds of species found nowhere else on Earth. These creatures evolved in isolation, becoming perfectly suited to the Australian landscape and remaining unique to that remarkable continent. Now, let's consider the crocodiles, those magnificent predators. Crocodiles naturally occur on every continent except Europe and Antarctica. In Africa, Asia, Australia, and the Americas, crocodiles have claimed rivers, swamps, and coastlines as their domain. But Europe, despite having many rivers and warm regions, has no native crocodiles. It does, however, have native snakes and lizards, creatures that thrive in European climates from the Mediterranean to more northern regions. Some reptiles have taken their relationship with water even further. Marine iguanas, found only in the Galapagos Islands, spend most of their lives in or near the ocean, diving down to graze on algae growing on underwater rocks. Sea snakes, elegant and graceful, rarely come to shore at all, living almost their entire lives in the warm waters of tropical seas. These ocean-dwelling reptiles remind us that reptiles have adapted to nearly every environment Earth has to offer. Living on islands, isolated from larger land masses, does something interesting to reptiles. Island reptiles often evolve unique body sizes or behaviors because they are isolated from mainland populations. Without predators, some grow larger than their mainland cousins. Without certain food sources, they learn to eat different things. Cut off from the rest of their species, island reptiles become their own unique variations, shaped by their small worlds. And this brings us to one of the most fascinating reptiles of all. The tuatara, found only in New Zealand, is the last living member of its entire reptile order. Imagine being the only one left of your kind, the sole survivor of a lineage that stretches back hundreds of millions of years. The tuatara's relatives walked the earth alongside the dinosaurs, but now, on a few protected islands off New Zealand's coast, only the tuatara remains, a living link to an ancient past, quietly reminding us how precious and fragile life can be. As you rest now, Perhaps you can picture these reptiles in your mind, scattered across the world, basking in the sun, swimming through clear water, living their quiet lives. Let that peaceful image carry you into sleep now as you continue to relax. Let's explore what makes a reptile a reptile. What is it about these creatures that sets them apart from all other animals? Let your breathing slow and we'll discover together the special characteristics that define this remarkable group. First, and perhaps most fundamental, reptiles are vertebrates. This means they have a backbone, a spine made of many small bones, stacked one upon another like building blocks. This backbone runs the length of their body, providing structure, support, and protection for the delicate spinal cord within. Whether it's a tiny gecko or a massive saltwater crocodile, each one is built around this central column of bone. If you were to gently touch a reptile, the first thing you would notice is its skin. All reptiles have dry skin covered in scales, or hard plates that help protect them and prevent water loss. Unlike the soft, moist skin of an amphibian, reptile skin feels different, almost like armor. These scales overlap, fitting together like roof tiles, creating a barrier between the reptile and the world, and this skin does something truly remarkable. The skin of many reptiles is almost waterproof, helping them survive in dry environments. In the desert, where water is precious and scarce, this waterproof coating means a reptile can keep the moisture it has inside its body rather than losing it to the hot, dry air. It's nature's own protective seal, perfectly designed. Here's something that might surprise you. Reptiles are cold-blooded, so their body temperature changes with the environment. Unlike you and me, whose bodies work constantly to maintain the same temperature, a reptile's temperature rises and falls, matching the air and ground around them. On a cool morning, a reptile is cool. In the heat of midday, its body warms. Because of this, reptiles often bask in the sun to warm up. You might see a turtle on a log, completely still, soaking in the sunshine, or a snake stretched across a warm rock, absorbing heat like a solar panel. This basking isn't laziness, it's how reptiles power their bodies, charging themselves with the sun's energy so they can hunt, move, and live. Despite many reptiles living in or near water, they all share one important trait. Reptiles breathe air only with lungs, even species that live in water. There are no reptiles with gills, no reptiles that can extract oxygen from water the way fish do. A crocodile beneath the surface, a sea snake in the depths, they all must breathe air. Take the sea turtle, for example. These graceful creatures spend nearly their entire lives in the ocean, gliding through the water, diving to feast on jellyfish and seagrass. But sea turtles must surface regularly to take a breath. They rise up, break through the surface, and fill their lungs with air before diving back down into the blue. Even in their watery world, they remain tied to the air above. Now let's look inside at the reptile heart. Most reptiles have a 3-chambered heart. 2 chambers receive blood, and 1 larger chamber pumps it out. This system works beautifully for most reptiles, efficiently moving blood through their bodies, delivering oxygen and nutrients where they're needed. But there's an exception. Crocodilians are unique because they have a 4-chambered heart. Just like mammals and birds, crocodiles and alligators have hearts with 2 separate pumping chambers, allowing them to separate oxygen-rich blood from oxygen-poor blood more completely. It's one of many features that makes crocodilians such successful predators, powerful and efficient. And here's something wonderful about reptiles. Because reptiles use less energy to stay warm, they can survive on far fewer calories than mammals. A mammal must eat constantly, burning food to generate heat to keep its body at the right temperature. But a reptile, drawing warmth from the sun and the earth, doesn't need nearly as much food. A large snake might eat once every few weeks or even months. A crocodile can go without food for long periods, patient and still, waiting for the right moment. As you lie here now, your own body warm and comfortable, imagine the simple efficiency of the reptile, living in harmony with the sun, breathing the air, protected by scales, ancient and perfectly adapted. Let that peace settle over you as you drift deeper into rest, as you continue to relax. Breathing slowly and deeply, let's enter the sensory world of reptiles. How do they experience their surroundings? What can they see, smell, and feel that we cannot? Close your eyes if you haven't already, and imagine perceiving the world as a reptile does. Many reptiles have an excellent sense of smell. For them, the world is filled with invisible messages, scent trails, and chemical signals, floating on the breeze, lingering on leaves and stones. These smells tell stories of prey that passed by. Hours ago, of rivals marking territory, of potential mates in the distance. The air itself is a library of information. Now picture a snake moving gracefully through the grass. Snakes use their tongues to collect scent particles from the air. Watch as the forked tongue flickers out and back in, again and again. It's not tasting the air exactly, it's sampling it, gathering tiny molecules, capturing the chemical signature of everything nearby. The fork helps the snake know which direction a scent is coming from, left or right, creating a map of smells. But collecting scents is only half the story. These particles are analyzed by a special organ in the roof of the mouth. It's called Jacobson's organ, or the vomeronasal organ, and when the tongue slides back into the mouth, it deposits those precious scent particles right onto this specialized sensor. There, in the darkness of the snake's mouth, chemistry becomes understanding, and the snake knows what is near. Some snakes have evolved something even more extraordinary. Pit vipers and boas and pythons have heat-sensing pits that detect warm-blooded prey. These small openings, usually located between the eye and nostril, are incredibly sensitive organs that can detect the infrared radiation, the heat, given off by living creatures. Even in total darkness, even if something makes no sound and gives off no scent, these snakes can see the warm shape of a mouse or a bird, glowing like a beacon in the night. It's a sixth sense, allowing them to hunt when other predators would be blind. Let's turn now to vision. Many lizards and turtles can see colors. The world for them is not gray or muted, but rich with hues. The green of leaves, the blue of sky, the red and orange of flowers and fruits. They use this color vision to find food, to recognize one another, to navigate their environment. Some researchers believe their color vision might even be better than ours in certain ways, and it gets more interesting still. Some reptiles can even see ultraviolet light. This is light that exists just beyond what human eyes can detect, invisible to us but perfectly visible to certain lizards and turtles. In ultraviolet light, patterns appear on flowers, on insects, even on other reptiles, patterns we can never see, a hidden layer of reality, painted in colors we cannot name. Here's something curious about snakes. Snakes do not have eyelids and instead have a clear scale over each eye. This transparent scale, called a spectacle or brill, protects the eye, keeping it moist and safe from dirt and damage. Because of this, snakes never blink, never close their eyes, not even when they sleep. They rest with their gaze forever open, watching the world, even in their dreams. Some reptiles have a feature so unusual, it sounds like science fiction. Certain reptiles, like the tuatara, have a light-sensing third eye on the top of the head. It's not an eye like the ones we think of. It can't see images or shapes, but it can sense light and darkness. This mysterious structure, covered by skin and scales, sits there on the top of the skull, monitoring the brightness of the world above. And what does this third eye do? This helps regulate daily and seasonal rhythms. It tells the tuatara and other reptiles that have it when day becomes night, when seasons change, when it's time to be active and when it's time to rest. It's an ancient timekeeper, helping these creatures stay synchronized with the turning of the earth. Finally, let's consider the desert lizard, racing across hot sand under a blazing sun. Some desert lizards have special scales that help keep sand out of their eyes. These modified scales form protective ridges like tiny awnings or visors, shielding the eyes from blowing sand and dust. Every detail of their bodies, perfectly designed for life in harsh places. As you rest now, Imagine seeing heat signatures in the dark, tasting scents on the air, watching the world through eyes that never close. The reptiles sense so much in their quiet way, perfectly attuned to their world. Let that thought comfort you as you sink deeper into peaceful sleep. Let your body settle even more deeply now, feeling the comfort beneath you, and let's watch how reptiles move through their world. Each species has found its own way, its own rhythm, perfectly suited to where it lives. Just observe and let these images drift through your mind, like a gentle documentary, playing softly as you rest. Most reptiles walk with their legs out to the sides of their bodies. Picture a lizard moving across warm stone. Its legs extend outward from the sides of its body, not beneath it like a dog or a cat. This sprawling posture, this sideways stance, is the ancient reptilian way. With each step, the body sways slightly, left and right, as the legs push, moving the creature forward. It's an efficient walk that has worked for hundreds of millions of years. But what about snakes, creatures with no legs at all? How do they move? Snakes move by pushing their ribs and belly scales against the ground. Inside a snake's long body are hundreds of ribs, and each one can move independently. The snake contracts muscles, shifting these ribs, pressing its belly scales against tiny irregularities in the surface below. Push and glide, push and glide. Like a wave flowing through the body from head to tail, the snake flows forward, smooth and continuous, turning its entire body into one elegant muscle dot in the desert, where sand shifts and burns under the sun. Some snakes have evolved a special way of moving. Sidewinder snakes use a looping motion to move across hot desert sand. Instead of sliding straight forward, the sidewinder lifts sections of its body off the scorching ground, throwing them forward and to the side, creating a series of parallel J-shaped tracks in the sand. Only two small portions of the snake's body touch the ground at any moment, minimizing contact with the burning surface, allowing the snake to move quickly, efficiently, across a landscape that would cook most creatures alive. Now imagine something that seems impossible. There's a lizard in Central and South America called the basilisk, and it can do something magical. Basilisk lizards can run across the surface of water for short distances. When threatened, they rise up on their hind legs and run, slapping their feet against the water so quickly with such force that they create little pockets of air beneath their feet. For a few precious seconds, a few precious meters, they literally run on water before physics catches up and they begin to swim. It's a gift given to very few creatures, this ability to break the boundary between land and water. Speaking of water, let's drift down beneath the waves, where sea turtles glide through the blue. Sea turtles have paddle-shaped flippers for long-distance swimming. Their front flippers, wide and flat, sweep through the water like wings through air, propelling them forward with powerful strokes. The rear flippers act as rudders, steering, stabilizing. These ancient mariners can swim for thousands of miles, crossing entire oceans, moving through the water with a grace that seems almost like flight. In rivers and swamps, other reptiles rule the water. Crocodiles swim mainly using their powerful tails. Those massive tails, thick with muscle, sweep back and forth, side to side, driving the crocodile through the water with surprising speed. Their legs tucking close to their bodies when swimming, reducing drag, making them sleek. The tail does the work, pushing, propelling, turning this armored predator into an underwater missile. Not all reptiles stay on the ground or in the water. Some snakes are excellent climbers and can move straight up trees or rock walls. They coil around branches, grip with their belly scales against rough bark, and pull themselves upward, defying gravity. Some can even bridge gaps between branches, stretching their bodies across empty air, finding holds where it seems none exist. The vertical world is theirs too. In the treetops, lizards leap and climb with confidence. Many tree-dwelling lizards have strong toes and claws for gripping branches. Some have toes with dozens of tiny ridges, creating surfaces so grippy they can cling to smooth bark or even glass. Others have curved claws, hooking into wood, allowing them to hang upside down, to race along the underside of branches, To live an entire life in the canopy where the ground is just a distant memory below. Back in the desert where the sand can reach temperatures hot enough to fry an egg. Some lizards have developed an amusing strategy. Certain desert lizards dance from foot to foot to avoid burning their feet. Watch one during the heat of the day, lifting one foot, then another, then another, then another, in a continuous little dance, a rhythm of survival. It looks almost comical, but it's deadly serious, keeping tender feet from cooking on sand that might be 60 degrees Celsius or hotter. Asterisk. And when threatened, some lizards simply disappear. Some lizards flatten their bodies to squeeze into narrow rock crevices. They turn sideways, exhale, compress themselves, and slide into gaps that look impossibly small. Once inside, safe from predators, they expand their bodies again, wedging themselves in place where nothing can pull them out. The rocks become their fortress, and they vanish into stone. Rest now, and imagine these many ways of moving. Walking, swimming, climbing, dancing. Each reptile finds its path through the world. Let that thought carry you, gently, peacefully, into deeper rest as you lie here, breathing slowly, feeling more relaxed with each breath. Let's explore the beautiful outer world of reptiles. Their skin, their colors, the way they transform and renew themselves. Let these gentle thoughts wash over you like colors blending into one another. As you drift towards sleep, reptiles shed their outer skin layer as they grow. Unlike us, who lose tiny flakes of skin constantly without noticing, reptiles release their old skin in a more dramatic way. As they grow larger, their skin doesn't grow with them, so periodically they must shed it. The old skin, no longer fitting, separates from the new skin beneath, and the reptile emerges fresh and renewed, wearing a brand new coat. For snakes, this process is particularly elegant. Snakes often shed their skin in one complete piece. The snake will find a rough surface, a rock or a branch, and begin to rub its snout against it, loosening the skin around the head. Then slowly, patiently, the snake crawls forward, peeling the old skin backward, turning it inside out like removing a sock until the entire length slides off in one translucent tube. Left behind is a ghostly replica, a perfect hollow sculpture of the snake that was. If you watch reptiles carefully, you can tell when shedding is near. Many reptiles look dull just before shedding and brighter afterward. Their colors fade, becoming cloudy and pale. Even their eyes may look milky. But after the shed, after the old skin falls away, the colors return brilliantly. The scales gleam. The patterns stand out sharp and clear. It's like watching something be polished, restored, made new again. Asterisk. Now let's talk about chameleons, those famous masters of color. There's a common myth about them, but here's the truth. Chameleons change color mainly for communication and temperature control. They don't change to match plaid shirts or chessboards as cartoons might suggest. Instead, a chameleon might darken to absorb more heat on a cool morning, or lighten to reflect heat in the midday sun. They flash bright colors to signal aggression, to court a mate, to say, "This is my territory," or "I'm interested in you." Their skin is a language written in shifting hues. For many reptiles, survival depends on not being seen. Many reptiles rely on camouflage patterns to blend into their surroundings. A snake in dead leaves is patterned in browns and tans. A lizard on tree bark wears grays and blacks that match the texture of wood. Some are so perfectly matched to their environment that you could stand inches away and never know they're there. They disappear, becoming part of the background, invisible, safe. But some reptiles do the opposite. Instead of hiding, they advertise. Bright warning colors can signal venom or bad taste. Coral snakes, with their bands of red, yellow, and black, are announcing danger. Poison dart frogs, relatives in the reptile world, wear vivid oranges, shocking yellows, patterns that say to predators, "Don't even think about it. I am not food. I am trouble." And predators learn and remember and leave the bright ones alone. In the desert, where the sun beats down mercilessly, color serves a different purpose. Some desert reptiles are pale to reflect sunlight. Light tans, soft creams, pale grays. These colors don't absorb heat the way dark colors would, instead bouncing the sun's rays away, helping keep the reptile's body temperature manageable. It's a strategy as simple as wearing white on a hot day, but built into their very skin. Some reptiles wear colors so vivid, they seem almost unreal. Certain turtles and snakes have pigments that create vivid blues and greens. These aren't just surface tricks of light, but actual pigments embedded in their scales and shells. The blue of a blue racer snake, the green of an emerald tree boa, the turquoise of certain sea turtles. Colors you might expect to see in tropical fish or exotic birds, living, breathing, crawling across land. And colors can change with the seasons with purpose. In some species, males become more colorful during breeding season. A male lizard that spent most of the year in modest earth tones suddenly blazes with orange throat patches, blue belly scales, vivid head colors. These temporary decorations attract females, intimidate rivals, announce readiness to mate. And when the season ends, the colors fade again, back to ordinary, until next year. Finally, there are the rare ones, the unusual ones. Albino reptiles lack pigment and appear white or yellow with pink eyes. Without melanin and other pigments, their scales and skin take on pale, ghostly shades. Their eyes, lacking the usual dark colors, reveal the blood vessels within, giving them that distinctive pink appearance. These albinos are rare in the wild, where their pale colors make them visible to predators. But when they survive, they're striking, beautiful in their difference, like living porcelain. Let yourself imagine. Now, all these colors, shifting, shedding, revealing, concealing. The reptiles wear their lives on their skin, telling stories in pattern and hue. As these images fade, let yourself fade with them, into the soft darkness of sleep, as you continue to rest, feeling the comfortable temperature around you. Let's observe how reptiles move through their days, governed by warmth and cold, living in rhythm with the sun. Breathe slowly and picture their patient routines as ancient as sunlight itself. The day begins quietly for many reptiles. Many reptiles bask in the morning sun to warm up. After a cool night, their bodies are sluggish, cold, slow. So they find their favorite spots, a flat rock, a sun-drenched log, a patch of sand, and they settle there, perfectly still. The sun rises higher, its rays touching their scales, and slowly, gradually, warmth seeps into their bodies. Their blood flows faster. Their muscles become responsive. The sun charges them like plugging in a battery, giving them the energy to begin their day. But the sun that gives life can also overwhelm. When temperatures rise too high, reptiles retreat into shade or burrows. There's a threshold, a point, where warmth becomes dangerous, and reptiles know it instinctively. When the rocks become too hot to touch, when the air shimmers with heat, they vanish into the shadows beneath bushes, into underground tunnels, into the cool darkness of caves and crevices. There they wait, patient, until the world becomes comfortable again. Some reptiles have solved the heat problem differently. Some reptiles are active mainly at night to avoid daytime heat. These nocturnal species sleep away the scorching hours and emerge when darkness brings cooler temperatures. Under the stars, they hunt, they move, they live. The desert comes alive at night with reptiles that never see the harsh midday sun. Creatures of moonlight and shadow, perfectly adapted to a nighttime world. Others split the difference. Others are most active at dawn and dusk. These twilight hours, when the sun is low, offer the perfect balance. Not too hot, not too cold. The light is soft. The temperature is moderate. At these in-between times, at the edges of day and night, these reptiles emerge. They feed during these brief windows, then retreat again, waiting for the next dawn. The next dusk dot. Throughout the day, reptiles make countless small adjustments. Reptiles carefully choose microhabitats to regulate their temperature. A lizard might move just a few inches from full sun to dappled shade. A turtle might shift from a warm rock to cooler water. These tiny movements barely noticeable, are how reptiles fine-tune their body temperature. The top of a rock might be 5 degrees warmer than the side. The surface might be 10 degrees warmer than 6 inches down. Reptiles read these invisible gradients and position themselves exactly where they need to be. Some have an even more sophisticated trick. Some reptiles can darken or lighten their skin to absorb or reflect heat. When they need to warm up quickly, their skin darkens, becoming better at absorbing the sun's energy. When they risk overheating, their skin lightens, reflecting more light away. It's an automatic system, responding to their body's needs, adjusting their relationship with sunlight, moment by moment. Crocodiles, massive and powerful, face a unique challenge. Their large bodies can overheat easily. Crocodiles sometimes bask with their mouths open to release excess heat. You might see a crocodile on a riverbank, jaws agape, looking fearsome, but it's simply cooling down. The blood vessels in the mouth release heat into the air like a radiator. It's called gular gaping, and it's perfectly normal. A giant predator, mouth wide open, just trying to stay comfortable. But what happens when the seasons change? When warmth fades and cold settles in? During colder seasons, many reptiles enter a state called brumation. It's similar to hibernation, but different. The reptile doesn't fully sleep, but becomes very still. Its metabolism slows dramatically. Its heart beats slowly. Time seems to stretch. The world outside grows cold, but the reptile waits, conserving energy, barely moving. In a state between waking and sleeping. During this time, brumation involves reduced movement and little or no eating. A reptile in brumation might not eat for weeks or months. It doesn't need to. Its slowed metabolism requires almost no fuel. It lives off stored reserves, waiting for warmth to return. Occasionally, it might shift position or drink a little water, but mostly it simply is existing, waiting, patient beyond measure. And here's something touching. Some reptiles brumate together in the same dens year after year. Garter snakes in northern regions, for example, gather by the hundreds or thousands in rocky dens. They return to these same sites, generation after generation. In the den, tangled. Together, sharing body heat, they wait out the winter. And when spring comes, when warmth returns, they emerge all at once, pouring out of the earth. A living river of snakes, returning to the world. As you lie here now, warm and comfortable. Imagine the reptile's relationship with temperature. How? They seek it, avoid it, adjust to it, sleep through it. Their entire lives choreographed by the sun. Let that slow, patient rhythm calm you as you drift deeper into your own peaceful rest. As you sink deeper into relaxation, let your mind wander to the question of how reptiles feed themselves. Each species has found its own way, its own strategy, honed over millions of years. Just listen, and let these stories of survival drift gently through your thoughts. If we look across all reptiles, we find one diet is most common. Most reptiles are carnivores. They are hunters, predators, eating other animals to survive. Insects, fish, birds, mammals, other reptiles. The world of reptiles is largely a world of meat eaters, creatures designed to catch and consume living prey. It's neither cruel nor kind, it simply is the way they've evolved, the way they live. But not all reptiles are pure carnivores. Some turtles and lizards are omnivores. They enjoy variety in their diet. A turtle might eat fish one day and aquatic plants the next. A lizard might catch a grasshopper in the morning and nibble on berries in the afternoon. This flexibility, this willingness to eat whatever is available, helps them survive in changing environments. When one food source becomes scarce, they simply switch to another, and a few have chosen a different path entirely. A few reptiles eat mostly plants. The green iguana, the desert tortoise, marine iguanas grazing on algae. These herbivores have specialized digestive systems, allowing them to break down tough plant material, to extract nutrients from leaves and flowers from fruits and grasses. In a world full of hunters, they are the peaceful grazers, the vegetarians of the reptile world. Now let's watch how carnivorous reptiles hunt. Many snakes are ambush predators. They don't chase their prey across long distances. Instead, they wait, coiled beside a trail, hidden in leaves, perfectly still. They might wait for hours or days. And then, when prey comes close, unsuspecting, the snake strikes, fast as a blink. The waiting is long, but the strike is instant. Patience and then explosive action. Some reptiles take a different approach. Monitor lizards, actively search for prey. These intelligent reptiles, cousins to the mighty Komodo dragon, patrol their territories. They investigate burrows. They climb trees, they swim through water. Always searching, always alert, using their keen senses to track down food. They are the tireless wanderers, covering miles each day. Persistent hunters who never stop looking. For some large snakes, the hunt ends with an embrace. Pythons and boas kill prey by constriction. Once they've seized their prey with their teeth, they coil their powerful bodies around it. Not to crush it, as many people think, but to squeeze it each time the prey exhales. The coils tighten gradually, relentlessly. The prey cannot breathe in again. Blood flow stops. Within minutes, it's over. The constrictor holds on a while longer, making certain, before beginning the long process of swallowing its meal. Other snakes have evolved a chemical weapon. Venomous snakes inject venom through fangs. Specialized teeth, hollow or grooved, connected to venom glands. The snake strikes, fangs sink in, and venom flows into the wound. Some venoms attack the nervous system, causing paralysis. Others break down tissue, beginning digestion before the prey is even swallowed. It's efficient, effective, allowing even small snakes to subdue prey much larger than themselves. Once prey is caught, reptiles face another challenge. Many reptiles swallow food whole or in large pieces. Snakes are famous for this, unhinging their jaws, stretching their flexible skulls to engulf prey that looks impossibly large. But lizards do it too, and crocodiles. They don't chew the way we do. They gulp. They swallow. The digestion happens later, slowly, powerful acids breaking down fur, bones, everything. Crocodiles, when they catch something too large to swallow in one piece, have a dramatic solution. Crocodiles use a spinning death roll to tear prey apart. They clamp their jaws on their prey, and then they spin, rolling powerfully through the water, using the momentum and torque of their entire body. The twisting motion tears chunks free. It's violent, primal, a technique that has worked for crocodilians since before the dinosaurs dot. And here's something remarkable about reptile metabolism. Some reptiles can go weeks or months without eating. That large python that swallowed a deer, it might not eat again for 2 months. A crocodile with a full belly, it could wait half a year before its next meal. This ability to fast, to survive on very little, makes reptiles incredibly resilient. They can endure droughts, food shortages, harsh seasons. They simply wait. Their bodies sipping slowly at stored reserves, patient as stone. Let yourself relax. Even more now, imagining these reptiles, some waiting motionless for prey, others searching tirelessly, each finding food in its own way, each surviving through its own adaptations. The hunt is over now, and so is this segment. Rest and drift into the peaceful darkness of sleep. As you rest here, safe and comfortable, let's explore the clever ways reptiles protect themselves. In a world full of dangers, they've developed remarkable strategies, some surprising, some almost magical. Let these stories of survival wash over you, gentle as waves. As you breathe slowly and deeply, one of nature's most astonishing tricks belongs to certain lizards. Some lizards can drop their tails to escape predators. Imagine being grabbed by a predator, its jaws clamped around your tail. In that moment of crisis, the lizard does something extraordinary. Special breaking points in the tail vertebrae allow the tail to simply detach. The predator is left holding the tail, while the lizard runs to safety. It's called autotomy, self-amputation, a last resort that saves lives. But here's the brilliant part. The wriggling tail distracts the attacker. The severed tail doesn't just lie there. It writhes, it twitches, it moves in wild, unpredictable ways. The predator's attention locks onto this moving thing in its mouth, while the lizard, now tailless, escapes into the bushes. Later, over weeks or months, the lizard will grow a new tail. Not identical to the original, but functional enough. A small price to pay for survival. Some reptiles have defenses that seem almost unbelievable. Horned lizards can squirt blood from their eyes. When threatened by certain predators, these small, spiky lizards restrict blood flow from their heads, building pressure in tiny vessels near their eyes, and then they rupture them. A stream of blood shoots out, sometimes several feet. The blood tastes bad to many predators, and the shock of it, the strangeness, often makes the predator retreat. It's bizarre, unexpected, effective. Many snakes rely on simple intimidation. Some snakes flatten their heads to look bigger. A harmless water snake, when threatened, might spread its head wide, making it look triangular like a venomous viper. The transformation is instant, from round-headed to wedge-headed. Many predators and many humans mistake these harmless snakes for dangerous ones, and that mistaken identity saves the snake's life. Others have evolved an audible warning. Rattlesnakes warn predators by shaking their rattles. At the end of the tail, a series of hollow segments, made of keratin like your fingernails, fit loosely together. When the rattlesnake vibrates its tail, these segments knock against each other, creating that distinctive buzzing sound. It's a warning that carries far. Stay away. I am dangerous. Do not come closer. And most creatures hearing that sound wisely retreat. Even snakes without rattles have learned this trick. Other snakes hiss or vibrate their tails in leaves. A rattleless snake in dry leaves or grass can create a similar buzzing sound by rapidly vibrating its tail. The leaves rustle and buzz, mimicking a rattlesnake. And they hiss too, forcing air through their throats, creating that serpentine warning sound, ancient and unsettling. I am here. I am not prey. Leave me be. Some reptiles use color as a decoy. Brightly colored tails can distract predators. Young blue-tailed skinks, for example, have brilliant blue tails that practically glow against their dark bodies. When a predator approaches, the lizard waves its tail, drawing the attacker's attention to this bright, moving target. The predator strikes at the tail breaks off, and once again the lizard escapes. The bright color, directing the attack to the one part of the body the lizard can afford to lose. For turtles, the defense is architectural. Some turtles can pull completely into their shells. Head, legs, tail, everything withdrawn. The shell closes like a fortress. The openings, protected by tough scales. Inside the turtle waits. The shell is bone, fused to the spine and ribs, incredibly strong. A predator might push it, bite it, flip it, but cannot get inside. The turtle simply waits, patient, until danger passes. Crocodiles are masters of stealth. Crocodiles float with only eyes and nostrils visible. The rest of their massive body submerged. Their eyes, positioned on top of their heads, watch the world above. Their nostrils, also on top, allow them to breathe. But everything else, the powerful jaws, the armored body, the muscular tail, all hidden beneath the surface. They look like floating logs, harmless driftwood, until they're not. It's camouflage through minimalism, hiding in plain sight. And finally, some lizards have learned to disappear entirely. Some lizards can sand swim beneath the surface. They dive headfirst into loose sand, and using a swimming motion, they move through it like water. Their bodies glide through the grains, leaving barely a trace on the surface. Beneath the sand, they're invisible, safe from predators above, able to travel hidden through their desert world. When danger passes, they emerge again like a submarine, surfacing. Each defense, a solution to a problem. Each trick refined over countless generations. The reptiles survive through cleverness, through adaptation, through the simple determination to live another day. Let that resilience comfort you now as you sink deeper into peaceful, protected sleep. As we come to the end of our journey, as you drift in that peaceful space between waking and sleep, let's discover one last truth about reptiles. They are not always solitary. They communicate, they recognize one another, they live sometimes together. Let these final thoughts settle over you like a soft blanket. As sleep finally claims you, we often imagine reptiles as lone wanderers, but this isn't always true. Some reptiles live in family groups. Certain skinks, some crocodilians, even a few snake species maintain bonds with relatives. Mothers with offspring, siblings staying close, small communities sharing basking sites or shelters. These bonds might last weeks, months, sometimes longer. Reptiles, like so many creatures, sometimes choose company over solitude without voices. At least most of them. Reptiles speak in other ways. Many reptiles communicate through body language. A head bob means one thing, a push-up display another. The angle of the body, the position of the tail, the tilt of the head, each posture carries meaning. This is my territory. I'm ready to mate. Back away. I submit. Silent conversations, happening all around us, in a language of movement and gesture. Some messages are chemical. Some use scent markings to signal territory. Special glands, producing distinctive odors, rubbed onto rocks, onto branches, onto the ground. Other reptiles passing by taste these marks with their tongues, reading the messages left behind. I was here. I am strong. This space is claimed. Invisible boundaries drawn in scent, respected by those who can read them. Even before birth, communication begins. Baby crocodiles call from inside their eggs. High-pitched chirps and grunts, muffled by the shell, but audible to their mother nearby. We're ready. Help us. The siblings call together, sometimes synchronizing their hatching, so they emerge as a group rather than one by one. The mother hears and responds, uncovering the nest, greeting her chirping children. Adult crocodilians can be quite vocal too. Alligators can produce loud roars during breeding season. Deep, resonant bellows that travel far across the water. Males calling, announcing their presence, their strength. Females listening, evaluating. The water around a bellowing alligator vibrates, ripples dancing on its back, visible proof of the power in that sound. It's primal, ancient, a voice from the age of dinosaurs. Lizards too have their displays. Male animals display colorful throat fans. Called dewlaps, these flaps of skin beneath the chin can be extended suddenly. Flash of orange, flash of pink, flash of red. The male bobs his head, extends his dewlap, claiming a branch, courting a female, challenging a rival. The color, the movement, impossible to ignore. A little lizard, making himself big, making himself seen. Courtship among reptiles can be surprisingly gentle. Some turtles use gentle movements during courtship. A male turtle might swim in front of a female facing her, and flutter his long claws against her face, soft as a butterfly's wings, or circle her slowly, head bobbing, shell touching shell. These underwater dances, slow and ritualized, are tender moments. In the lives of creatures we often think of as emotionless, reptiles know one another. Reptiles can recognize rivals and adjust behavior. Studies show that lizards remember other individuals, knowing which ones are strong, which ones they've beaten before, which ones beat them. They adjust their aggression accordingly. Less display toward the one they know they can't beat. More confidence toward the one they've dominated. They're not mindless. They remember. They learn. They adapt their social strategies. And like so much in the reptile world, social behavior shifts with time. Social behavior can change with the seasons. Solitary most of the year, gathering to mate. Aggressive in breeding season, tolerant in winter. The same individual, friendly or hostile, depending on the time of year, the weather, the circumstances. Reptiles, like us, are complex. They change, they adjust, they respond to their world. Even the youngest ones sometimes seek company. Even young siblings may bask or shelter together. Baby geckos huddled under the same bark. Young snakes coiled together in a crack in the rock. Hatchling turtles traveling together toward the sea. These temporary alliances, these sibling bonds, don't last forever, But for a little while, the young ones find comfort in not being alone, and so we see that reptiles are more than we often imagine. Not cold in heart, just cold in blood. Not unfeeling, just feeling differently. They communicate, they bond, they remember. They live their lives with purpose, with adaptations refined over unimaginable spans of time. Ancient, yet still here. Still thriving. Still evolving. As you rest now, think of the reptiles, scattered across the world, basking in morning light, swimming in dark water, hiding in cool burrows, living their quiet lives. The world is full of them, these scaled survivors, these masters of adaptation. And now you know them a little better. Let yourself drift now completely. The journey is complete. The facts have washed over you like gentle waves, and now there is only rest, only sleep, only the soft darkness pulling you down into deep, peaceful, restorative sleep. Rest well and dream of the ancient world of reptiles if you dream at all.